in the section 3 practice, I'm just going to do a couple more examples of division for you. So just to kind of review, if you're dividing a polynomial by a monomial, so that is when you have one term, you can split it up into separate divisions. When you are performing long division, we do want to double check that the polynomial is in descending order. Otherwise, we won't get the correct answer. When performing synthetic division, also with long division, we want to make sure we account for missing terms with 0. So if you go from an x squared just to a constant, we want to make sure we account for that missing x term with a 0. And then synthetic division can only be performed when dividing by a binomial of degree 1. So that's something like ax plus b. So just an x term and a number that's being added or subtracted. So just have a few examples here that I'm going to do. So the first one is an example where I have a polynomial divided by a monomial. I have 8x to the 5th minus 6x squared plus 12x minus 20 divided by 2x. So I'm going to split it up. 8x to the 5th over 2x minus 6x squared over 2x plus 12x over 2x minus 20 over 2x. So when we're dividing, we divide coefficients, which are the numbers in front, but we subtract exponents. So we have 8 divided by 2, which is 4, and then x to the 5th over x is x to the 4th, minus 6 divided by 2 is 3, and then x squared over x is x, plus 12 divided by 2 is 6, and then the x's are going to cancel, so I have 1 each, minus 20 divided by 2 is 10, over, and then the x is still in the denominator because there was nothing to divide it by. I heard someone refer to it as reverse distribution the other day. I think it's a great example. When we're dividing polynomials, we're trying to figure out what I multiplied in order to get that answer. So 2x times what is 8x to the 5th minus 6x squared plus 12x minus 20. So if I did 2x times 4x to the 4th minus 3x plus 6 minus 10 over x, and I distributed that 2x into the parentheses, I would end up with what I started with in my numerator. So that's the goal of division, to figure out what two things multiply together to give us our numerator. So our next example, 2x cubed plus 12x minus 1 divided by x plus 2. And I'm going to go ahead and do this example with long division, just so you can see long division with missing terms one more time. So when we set up long division, I'm going to put what we're dividing by in front, which is x plus 2, and what we're dividing underneath. So 2x cubed, and then if I look, I go from 2x cubed to 12x. So I don't have an x squared term. So I'm going to put plus 0x squared, then plus 12x minus 1. So when we're performing long division, we're always dividing the terms with x. So I'm going to start by doing 2x cubed divided by x. And I'm going to get 2x squared. And that's going to go on top. Then I'm going to take 2x squared and multiply it to x plus 2. And we're going to get 2x cubed plus 4x squared. Now remember, this entire thing is being subtracted. So 2x cubed minus 2x cubed is going to cancel. And the reason I put the 0 is because I'm doing 0x squared minus 4x squared. So it's to remember that it's going to be negative 4x squared, not positive 4x squared. I'm going to bring down my next term, the positive 12x. And now I'm going to repeat. So negative 4x squared divided by x It's going to give us negative 4x. And then I'm going to do negative 4x times x plus 2. I'm going to get negative 4x squared minus 8x, which I'm going to subtract. The negative 4x squareds cancel. And in this case, I'm doing 12 minus negative 8x, which is going to change it to addition. So it's going to become 20x. Then I'll bring down the minus 1. Then I'm going to do 20x divided by x, which is going to get me positive 20. Then I'm going to do 20 times x plus 2. And I'm going to get 20x plus 20, which I'm going to subtract. My 20x's cancel. And then negative 1 minus 20 is negative 21. So at the top, I'm going to write my remainder plus negative 21 over what we divided by x plus 2. And that's going to be my final answer. So again, if I were to take x plus 2 and multiply it by what I have at the top and use distributive property and everything, I would end up with 2x cubed plus 12x minus 1. The last example I'm going to do is synthetic division. So I prefer to use synthetic division if I have a large degree polynomial. So anything that's to degree 4 or higher, I'm going to lean towards using synthetic division, just because long division for anything that's greater than degree 3 can get very time consuming. So I'm going to elect to use synthetic division here. So in my box, I'm going to take what I'm dividing by, x minus 1, set it equal to 0, and solve. So I'm going to get x equals 1. So I'm putting 1 in my box. Then I'm going to go through all of my coefficients. So I have 1x to the 5th, negative 2x to the 4th, 3x cubed, 9x squared, negative 1x, and positive 1. So I'm not missing any terms here. I'm going to put my vertical line between my last two numbers and then my horizontal line. I'm going to bring down my first number, 1. Now I'm going to multiply it by the number in the box, which is 1. Put it underneath my next number, and then I'm going to add. So negative 2 plus 1 is negative 1. Now I'm going to repeat. Negative 1 times 1 is negative 1. 3 plus negative 1 is 2. 2 times 1 is 2. 9 plus 2 is 11. 11 times 1 is 11. Negative 1 plus 11 is 10. 10 times 1 is 10, and 1 plus 10 is 11. So now that we have all these numbers, it's like, what do these numbers mean? So the number on the right side, this is always our remainder. Then starting with the first number on the other side, we always start with our constant, and then we work our way up into an ascending order with our degrees. So x squared, x cubed, and x to the 4th. Another important thing to remember here with synthetic division, since I have technically divided through by x, the degree of my answer can't be the same degree as what I started with, because I've divided by x, so it has to be 1 degree smaller. So we have x to the 4th minus x cubed plus 2x squared plus 11x plus 10, and then plus my remainder 11 over x minus 1. So what this tells me is if I would take that whole long equation that I just wrote and multiplied it by x minus 1, and I did all the distributing, which would be very time consuming, I would end up with x to the 5th minus 2x to the 4th plus 3x cubed plus 9x squared minus x plus 1. So hopefully this helps a little bit more with the process of long and synthetic division. If you still have any questions, please let me know.